Today I'm going to be solving this problem, k closest points to origin. Given an array of points where points I is xy represents a point on the xy plane and an integer k, return k closest points to the origin 0, 0. The distance between 2 points on xy plane is Euclidean distance square root of x minus x squared plus y1 minus y2 squared. You may return an answer in any order. The answer is guaranteed to be unique, except for the order that it is in. Automatically, when I think of returning k closest points, you're gonna have to sort the points by their distance from the origin, and you want the k closest points, so that'll be the k points that have the smallest distance from the origin. And so what you want to do is sort these points by the distance, and the data structure to do this would be using a heap. The heap is essentially a type of binary tree where you're sorting the points in a min heap or a max heap, where the min heap sorts the points from, it returns the minimum element each time, and a max heap returns the greatest element each time. What you want to do for this problem is use a min heap, and we want to sort our points with their distance. So we're gonna sort them with their distance, find distance from the origin to the point, and then sort this tree, the min heap. So, and then we're just gonna pop out the k closest points, and that's gonna be our answer. Right now I'm going to import my heap package. That's going to be create a heap for me. So I have my heap, which I'm going to start off as an array. And now I'm going to have my points. So I'm going to loop through my points. And I have my xy coordinates. So what I'm going to do now is I want to get a distance, which would be the square root. Well, you know that the square root is directly correlated to the Euclid is to x1 minus x2 squared plus y minus y2 squared. And since the origin is 0, 0, the distance will essentially be x squared plus y squared. So that's what I can do. I can just do this. I can just do x squared plus y squared. And then now I'm going to store this, as well as the point xy coordinates, into my min heap. So now I'm going to push the distance, the x value, and the y value to my min heap. Now what I do now is I'm going to have my resulting array, and I'm going to loop through my heap k times, get the k closest elements. I'm gonna get my distance, I'm gonna get my xy coordinates, and that's the popped off element in my min heap. Now I'm going to really store my xy coordinates. I'm going to append my xy coordinates to my resulting array. And now I'm going to return the result. Faster than 86%. So what's the runtime complexity of this? The runtime complexity of this would be O of n log n times, because what we're doing now is we're looping through our points, and n is the number of points in our points array. And every time you do a push operation on the min heap or max heap, it's going to be O log n time. And since you're doing this n times, you multiply n times log n, and you get the time complexity of O n log n times. And that's our time complexity, and our space complexity of this would be O of n as well, because we're creating a heap, and of n nodes, of n points. Alright, thanks guys.